Well, once again, good evening, students, ladies and gentlemen. Arthur Johnson speaking, and I hope that you are doing well. And it's my pleasure to join you tonight for another talk. This is the subject I've chosen after some consideration. I've not done this lecture before for this class, so this is some new work, and I hope you'll enjoy it. Ideally, in semesters to come, I'll get it down better. But anyway, tonight I'm going to speak with you about asteroids. However, just as a bit of housekeeping, I want to hark back to my subject of a few lectures ago, and that is comets. Now, this is about as current as it gets. There's a comet that's been approaching inner solar system called Comet Atlas, and you may recall my telling you about it and suggesting that there was at least some hope that it would become quite good, spectacular and bright perhaps. Sadly, it is not so. 2 nights ago, I believe, this automated telescope set of images came in and it reveals that the comet is in process of disintegrating. Now, what are we looking at? In the main frame, you see some long streaks, and then you see the comet. Well, the telescope was programmed to track the comet as it moved in its orbit. And so, over a period of some minutes or maybe even a couple of hours, the stars made smears and trails, and we got a nice, good close up of the nucleus, the solid stuff of which Comet Atlas is made. And as you can see very clearly in the little upper left-hand inset picture, the nucleus is fragmenting, and that does not bode well for it to continue getting brighter. In fact, over the last week, it has dropped in brightness from about magnitude 7 to magnitude 8. So it looks like it's going to be a fizzle, and that's not without precedent. Here is a most wonderful animation that goes back, 2006. The Hubble Space Telescope made a series of observations of Comet Vossmann-Bachmann, and it had been known to undergo violent changes in brightness, and here we can actually see textbook example of a comet breaking up and shedding chunks of its icy self. So I fear that the much vaunted Comet Atlas we have been hoping to see in May of this year will not turn out to be all that great. But anyway, you heard it here first. So on to asteroids. Well, the name was suggested by William Herschel, the man who found the first planet ever discovered by an identified human being. That was, of course, the planet Uranus, which he found back in the 1780s, as I recall. He suggested that this new discovery that was made in Italy might be called an asteroid or little star. Now, it's interesting that first asteroid, which I'll show you a picture of in just a moment, was actually noted and plotted on a star map by none other than Galileo, way back when he was observing in the early 1600s. But he mistook it for a star, he just noted its position and went on to do other things. But after Ceres was discovered, astronomers and historians went back, and sure enough, Galileo had seen this asteroid. I'll come to the story of its discovery. I'll just point out here that after the discovery in 1801, in the next half century, the number of asteroids detected went up to 15 total. So, just to recap, after Herschel completely astounded the whole world by finding that there was a new planet after the 5 that were known to the ancients, naturally astronomers began to wonder, well, if one could be found, might there be found another? And intriguing evidence began to suggest that this was really more than a little bit likely, because Uranus, after its orbit was determined, failed to follow that orbit exactly. It deviated a little bit as the years went by and astronomers marked its progress on star charts. They saw that it wasn't going in quite the direction and quite the orbit that Newton's law of gravity said it should. So the speculation was, well, could there be some other planet as yet unknown even farther away that is exerting a gravitational force on Uranus and causing it to deviate from its predicted path. To solve this problem was an enormously difficult mathematical undertaking, particularly in the days when there were no mechanical or electronic computers, but two mathematicians, a Frenchman named Leverrier and an Englishman named Adams, tried to do it. They both tried to solve the three-body problem and in fact independently came up with a solution. They both predicted where that eighth planet must be found, and when a German astronomer pointed his observatory telescope in that direction, within a very short while, he glimpsed Neptune. Well, parenthetically, of course, the French and the English have been known to feud and fight about a few things. One or two wars happened somewhere along the way, and there was a violent argument as to who should be credited with the discovery. Was it Monsieur Leverrier or was it Mr. Adams who really got it right? Well, today we give honor to both of those men. So there it is. This is Ceres, the first asteroid to be discovered and the largest. It was found the first day of 1801 by Piazzi in Italy. We have come to know that it is almost 600 miles in diameter, by far the largest of the asteroids. And with the naked eye, under ideal conditions, if you have young eyes and 20/10 vision, you might just be able to glimpse Ceres looking like a faint star. Ceres lies in the classical asteroid belt, which I'll have more to say about shortly. Its orbit lies between the orbits of planet Mars and planet Jupiter, and it takes 4.6 Earth years approximately to complete one journey around the Sun. It is the only one of the asteroids whose gravitational field is sufficiently strong to force it, pull it into a spherical shape. This wonderful photographic montage was made possible by a NASA spacecraft named Dawn, which went to Ceres in the year 2015. And by the way, today we consider that Ceres and Pluto are really in the same category. They're very comparable in size. We refer to them as dwarf planets, and I was a bit heartbroken that Pluto got demoted, but hey, that's how science works. This is just a larger view of that video of Ceres rotating. Well, as I said, after the first one was found, other astronomers went looking for more asteroids, and it was slow but steady. By the time 1849 came around, something like 10 asteroids had been found, and then it really picked up, especially after photography came into practical use in astronomy. By 1868, there were 100 asteroids known, and you can see how it went. 1,000 by 1921, more and more and more, and today the number is just about 1 million asteroids. This picture is one I took some good many years ago. It's our own moon, of course. And the point to be made by the picture, well, there are 2 points. One is that all the asteroids that are known to exist do not equal in mass the Earth's moon. So they're tiny, tiny little things in comparison with the moon. If you taped all of them together, you would not get enough to equal the mass of the moon. The second point I make, however, is a more subtle one, maybe. We see that our moon, of course, is covered with craters. And how did the craters get there? When I was a very young kid studying astronomy, there were still people holding forth to the theory that it was volcanic activity that caused these round holes on the moon. Others believed that it was the impact of rocks from space, meteorites, asteroids, whatever, that bombarded the moon and made these holes. And today that is considered by far the leading candidate. We are just about certain that these craters were formed by the impact of rocks from space. Now, if the moon has them, so also have other planets. Mercury is covered with craters. Some of the moons around Jupiter, whose surfaces we can see, are cratered. And the Earth, too, has been bombarded. And some of you may have been to visit the Arizona Barringer meteor crater, sometimes called meteor crater. It's between Flagstaff and Winslow in central Arizona, and it was made about 100,000 years ago. This is a simplified view of where the asteroids can be found. This would have been typical of a grade school textbook or astronomy book from the 50s and 60s. It's very neatly shown that all the asteroids are between the orbit of Mars and the orbit of Jupiter. That's a simple way to think of it, and it is approximately true, but there are many exceptions. Look how many. The green dots in this computer-generated diagram are the classical or traditional asteroid belt, which lies roughly 2.2 to 3.4 astronomical units from the Sun. That is to say, between the orbits of Mars and Jupiter. But there are many others. The red ones are going to be of some interest to us as we continue with our talk tonight. Those are the near-Earth asteroids. Again, more to be told later. Here is a wonderful, wonderful computer-generated graphic from Caltech that shows the asteroids, the outer belt in orange, and the blue inner belt would be the near-Earth asteroids. So until the space age, nobody knew what an asteroid looked like, even with the most powerful of telescopes. They could only be seen as little stars. They were simply too small, too far away for us to know something about them. But that began to change in the last couple of decades of the 20th century. The most famous of all space probes probably was Galileo, which went to visit Jupiter and about which I could speak for another entire lecture some other time. But although its main target was Jupiter and its moons, on the way to Jupiter, Galileo probe went past 2 asteroids. And before we get into those, I'll just give you some basic categorizations, what we have come to know about the asteroids and what they're made of. We have the C-type, which are carbonaceous, the type S for silica or siliceous asteroids, and the rarest type, the metallic M-type. Very interesting, and I'll have, again, things to tell you about that as we go forward. Well, on its way to Jupiter, the Galileo probe first encountered this asteroid, Gaspar. It is roughly 11 by 6 miles in diameter and roughly about the same size as Hong Kong. And it's interesting to note that this asteroid itself is covered with craters. So what this implies is that over the 4.5 billion years of our solar system's existence, all manner of rocky things and metallic things crashed into one another. Sometimes asteroids hit other asteroids. Very early on, planets may have collided. The Earth and its moon may have suffered an impact at one point, it is thought. But craters, there they are, all manner of things crashing through the universe, through the solar system, and impacting on one another. So this compares with the St. Louis, Missouri area. There it is. Food for thought, maybe. So I've been pointing out asteroids, and some that you'll perhaps have noticed that all of them are numbered. And that's a practice that started in 1801, and it continues right up to this day. After they got to about 40 or 50 asteroids, astronomers sort of gave up trying to find names of gods and goddesses from Roman and Greek mythology. But about the first 50 asteroids have names similar to that. After that, something more mundane came to pass, and up to this day, it continues. The discoverer of an asteroid gets to suggest a name for it, and that name is either given the thumbs up or thumbs down by an international body. Nearly always the names get approved. That has to be pronounceable in some language. It's not supposed to be offensive, and you can't name it after Rover or Fluffy. Here are some funny names that have come to be over the years. I'm going to talk now about some asteroid news that is very current. In fact, if you take the magazine Sky and Telescope, the cover story for the current issue is all about two asteroids that are right now being robotically explored. And in fact, both the robots, one from the Japanese Space Agency, the other from NASA, have as their goal to touch down on the surface of the asteroid, to take all manner of pictures and videos, and eventually to return a soil sample or a rock sample back to Earth. So that's supposed to happen. This one is Ryugu, a Japanese name, and it is again generally the prerogative of the discoverer to pick a name, and people tend to reach into their own culture to honor some person. So here's Ryugu. It's just a little one. It's only about 1 kilometer in diameter. It is a type C, carbonaceous meteorite, and that is the second most common type after the silica or silicaceous meteorites. The Japanese spacecraft named Hayabusa 2 got to Ryugu in November of last year, just last Thanksgiving time, more or less. It landed. It sent an impactor down to make a crater, and the orbiter took pictures of what happened. And turns out that crater was something like 13 meters in diameter, much bigger than they had expected. From that, the conclusion was drawn that this asteroid is, to put it as we have it here on the bottom of our slide, it's nothing but a rubble pile. There's not a smooth area on it. It's just an accretion of smaller meteoritic pieces, rocks, boulders, dust grains, and so forth. Here is the orbit that's been calculated for Ryugu. It's marked in white in this diagram, and you can see that Ryugu is in the family of near-Earth asteroids. It can come pretty close to Earth's orbit, and at its furthest point, it gets out not quite to the orbit of Mars. So this would be one of the sometimes called Atlas family of inner asteroids, the ones that could conceivably come near the Earth or hit it, okay, about which more later. Oh, I mentioned the impactor, and here's a before and after picture. Excuse me. You can see the before picture on the left, and after the small impactor from the craft smashed into the asteroid. I'm sorry, it's 10 meters, not 13 meters, but still a pretty substantial pockmark in the surface of this asteroid. Here's the other one, a little bit bigger than Ryugu, and this one's Bennu, which is an Egyptian name. It was a mythical bird in Egyptian mythology. Bennu was found fairly recently, so you can see its number reflects that, 101,955. That's the number, the serial number of its discovery, going back starting in 1801. It was discovered in 1999. It is, like Ryugu, a type C or carbonaceous asteroid, and it has been and is now being visited by a NASA spacecraft called OSIRIS-REx, launched at the end of 2018. The operators of the craft are presently surveying the asteroid, trying to ascertain what would be the most interesting spot for the landing, which is supposed to happen just towards the end of this summer of 2020. One of the astounding things we found about it is that it spits out from time to time, it erupts little clusters uh, or shards of rock from beneath its surface. This is found to be an asteroid that has abundant water ice below the surface, and one can imagine that it must be this heating of the ice by solar radiation that is causing these outbursts of little tiny meteoritic particles. When I lectured about comets a couple of weeks ago, I talked about the fact that meteor showers are thought to be debris ejected by comet nuclei. And I cannot help but wonder, looking at this amazing picture, if what we're seeing here is not a meteor shower that someday will happen as this asteroid expels little fragments of itself into the solar system. Here's a most wonderful graphic showing the rotation of asteroid Bennu. Great big cosmic rubble pile, not much more, certainly no differentiation, no molten core. It's not big enough to have a thermal source at its core. It's just a great big accretion of a gravel pile, so to speak. Well, this brings us to our third class of asteroid, which I think is pretty cool, and I tried to save the best for last. We're speaking now about the so-called M type, M for metal, yeah, metallic asteroids. They are known to exist. They're not very many. About 8% of all asteroids are thought to be of this type. We have not sent a spacecraft out to see one yet, so this is the best that a land-based telescope has been able to do to image Psyche, asteroid 16 Psyche, discovered in 1852. And it's solid metal, folks, and it only gets stranger from here. It is thought to be the remnants of the core of an unformed planet. Not quite sure how that has been determined, but spectral analysis, the color of the light that is reflected tells us this. Also, we know that it is very, very dense, way dense. It's got to be made not only just of solid metal, but in particular, nickel, iron, gold, and platinum. This made the news about 2 years ago, and you may well have seen it. Of course, the National Enquirer took this story and ran with it. But there's enough gold there, apparently $10,000 quadrillion worth of gold. So were this asteroid to be mined and brought back to Earth, it would cause gold to be essentially worthless. NASA has devised a mission to launch to go and visit Psyche, and that launch date is coming up in just 2 years, in 2022, and it is scheduled to get to Psyche in 2026. So put that on your calendar, if you will. And artists had a lot of fun with this imaginary picture, painting, supposedly showing us a solid gold, platinum, iron, nickel asteroid, yours for the mining, if you can figure out how to do it. Well, I'm going to conclude with something that's a little sobering, but it's also in its own way reassuring. I mentioned at the beginning of the talk that Earth and Moon are displaying craters. We know that in the early billions of years of the solar system's existence, meteoritic objects, asteroids, giant rocks were crashing into planets all over the place, and craters were being formed frequently, huge craters on the moon, even hundreds of miles in diameter. We have heard, in my lifetime, it's gone from a far-out theory to pretty much accepted fact that the death of the dinosaurs and the demise of 90% of life forms on Earth can be attributed to a huge asteroid impact. And I don't know if I have the name right. It's a Mayan name, Chicxulub, maybe. If you can do better, I would like you to tell me that. But we now have almost irrefutable evidence that an asteroid between 10 and 50 miles in diameter struck the Earth just north of the present Yucatan Peninsula, something like 66 million years ago, and profoundly changed the evolution of life on our planet. The dinosaurs, 90% of other animal life was wiped out in the winter that followed. The bit of philosophical hope here is that, in fact, human beings did come on the scene. We've been here a long time. We have had our own human history of some tens of thousands of years anyway, and we have not yet been wiped out by the impact of an asteroid. Now, very seriously, it could happen. The late Carl Sagan, and I heard him interviewed in an encore presentation on NPR not very long ago. And his solemn notion was that an asteroid impact was the greatest non-human threat to wiping out our kind, and it was because of that risk that Sagan believed we should colonize Mars and hedge our bets in sending our human DNA out to another world, because in fact the Earth could be rendered uninhabitable if another asteroid were to strike. Well, scientists have given some credence to this, and governments have seen fit to sponsor a couple of projects to look for near-Earth asteroids and try to detect them far enough in advance that conceivably something could be done to divert them, blow them up, move them onto a different path. And it's still literally rocket science. We can't do it right now, but it does seem in our interest to continue hunting for asteroids that may someday give us a threat. And in fact, since 1998, there have been 2 scientific projects undertaken. The first being Project Linear, which is an acronym for the Lincoln Near Earth Asteroid Survey. And then the successor, which is ongoing now, is the Catalina Sky Survey, operated from the Catalina Mountains near Kitt Peak in southern Arizona. And this project scans the heavens essentially every clear night of the year, looking for potential threats. And along the way, something like 250,000 new astronomical bodies in near-Earth orbit have been found. With that, I am going to come to the end of our video presentation and clear my throat, and I shall stop the video now, and in just a moment I shall take your questions live. Thank you so much for your attention.